All right, chapter 10, section 3 is all about finding the area of regular polygons. So first, a review on what does it mean for a polygon to be regular. It's just a polygon with all sides congruent and all angles congruent. We talked about this a couple months ago. And so just reviewing that definition, all the sides are the same and all the angles are the same. So when we have a regular figure, we have a couple of terms that we need to talk about. And the first is radius. So you're probably used to radius being talked about in terms of circles, and it works pretty much the same with a regular polygon. We have a center of the polygon right here, and the radius is just the distance from the center to one of the vertices out here. So if we connect this center to any of these vertices, that would be the radius. And then we have another term called an apothem, which goes from the center to one of the sides and makes a right angle with one of the sides. So we've got an apothem here, connecting the center straight down to a right angle. The opposite side, radius, connects the center to a vertex. We also have another term, a central angle. So when we have a regular polygon, we can draw the different radiuses of the shape. And if we draw two that are next to each other and measure this angle right here, that's a central angle. And so here we have a hexagon, so we'd have 6 central angles. We'd have one here, one there, one there, one there, one there, and one there. So central angle, 2 consecutive radii connected together, measure the angle between them. All right, so first thing we're going to do is we are going to find the angle measures of angle 1, angle 2, and angle 3. And this is an octagon, 8-sided figure. So number 1, that would be a central angle. These dotted blue lines are different radii of the octagon. And so as you can see, since it's an octagon with 8 sides, there's actually 8 central angles. 1, 2, 3, 4, 5, 6, 7, 8. And we know that there are 360 degrees all the way around in a circle. So if we have 8 central angles for an octagon, all we do to find angle 1 is just divide 360 by 8, and angle 1 is 45 degrees. Now you'll notice angle 2, that's just half of a central angle. From here to here would be 45. So to find 2, we just need to divide that by 2. And we get 22.5 here, and we'd also get 22.5 right here. And now to find angle 3, we have a triangle, a 90-degree angle, a 22.5 degree angle, and angle 3. So 180 degrees between them means that this plus this has to be 90. So if we do 90 minus that 22.5, we get angle 3 being 67.5. All right, why are we doing this? Because we're going to have to do this when we want to find the area of one of these shapes. So if I want to find the area of a regular polygon, we have a formula. 1/2 the apothem times the perimeter. So again, the apothem is this dotted red line here going from the center, making a perpendicular angle to one of these sides. And the perimeter is just the entire perimeter of the shape. So in this case, since it's an octagon, we would need to multiply the side by 8 because there's 1, 2, 3, 4, 5, 6, 7, 8 sides of the polygon. So the perimeter would be 8 times s. So let's look at an example. So find the perimeter and area of the figure shown. First thing you should ask yourself is, what type of shape do I have? Hopefully you can see that this is a decagon. There's 10 sides here. So the perimeter, if each side is 8, there's 10 sides, simple enough. 10 times 8 is 80. Then to find the area, we need to use our formula 1/2 the apothem times the perimeter. In this case, they gave us the apothem, it's 12.3. So we do 1/2 the apothem times the perimeter we just found, and we get an answer of 492 inches squared. Again, notice the unit here is square inches because it's an area, where here for perimeter, it's just a distance, regular inches. Okay.